You are reading this on glass. You did it this morning when you turned off your alarm. You do it hundreds of times a day, without thinking about it, without knowing where it came from. Every time your finger touches a screen, a piece of glass a few millimeters thick measures the electrical field of your body, calculates the coordinates of your touch to within a fraction of a millimeter, and sends that signal to a processor faster than you can consciously register that you've touched anything at all. This technology is worth over $70 billion today. It runs on 7.2 billion active devices. It lives in every pocket, on every factory floor, in every hospital, in every airport on the planet. It is the primary interface between human beings and almost every piece of technology built in the last 20 years. And it was invented by a man whose name you have almost certainly never heard. January 9th, 2007, San Francisco, the Moscone Center. Steve Jobs walks onto a stage in a black turtleneck and jeans and smiles. 3,000 people in the room, millions watching on screens. Today we're introducing 3 revolutionary products: a widescreen iPod with touch controls, a revolutionary mobile phone, and a breakthrough internet communications device. These are not 3 separate devices. This is one device. We're calling it iPhone. The room erupts. We have invented a revolutionary user interface, based on a technology we've developed called multitouch. He wasn't lying. He did change the world. But the word invented, that's a different question. Because on the day Steve Jobs announced his revolution, that revolution was already 42 years old. 1965. Busiest England. Population 12,000. Rolling hills, fog, Victorian houses. Inside the Royal Radar Establishment, a classified British military laboratory, an engineer named Eric Arthur Johnson is solving a specific problem. Air traffic controllers sit in front of radar screens. When they need to mark a target, they reach for a separate keyboard, type the command, return to the screen. Slow. Awkward. In an emergency, dangerous. Johnson's question is simple. What if they just touched the screen? In October 1965, he publishes a 2-page paper in Electronics Letters. Touch Display, a novel input-output device for computers. In those 2 pages, everything. Glass, a conductive layer, an electrical field. A finger changes the capacitance. The system registers the coordinate. The basic principle of every touchscreen on Earth right now. In 1969, he receives his patents, both British and American. And then, nothing. The technology doesn't go into production, doesn't attract investors, doesn't reach the market. Johnson's own employer, the British military, wouldn't deploy touchscreen interfaces in their air traffic control centers until the 1990s, 30 years after he built the first one. Eric Arthur Johnson continues working in his laboratory. His name disappears from the history of technology. Johnson wasn't alone. While he was working in Malvern, the same idea was emerging independently across the world. In 1971, Samuel Hurst, an engineering instructor at the University of Kentucky, invented resistive touch, 2 conductive layers that make contact under pressure. He called his device the Elegraph. Different technology, same concept. Touch the screen, the machine understands. In 1972, at CERN in Geneva, engineers Frank Beck and Bent Stumpe built a capacitive touchscreen to control a particle accelerator. On March 11th, Stumpe wrote out a handwritten technical proposal. Copper conductors etched onto glass, 80 microns wide, invisible to the naked eye. When CERN's superproton synchrotron started up in 1976, its control room was fully equipped with their touchscreens. CERN is not a company. It's not a market. The screens worked perfectly and stayed inside a nuclear laboratory. By the mid-1970s, 3 independent teams on 2 continents had built working touchscreen technology. So why didn't it go anywhere? 3 reasons. Cost. Transparent conductive materials and precision etching were expensive. Computing power. Processing touch data in real time required hardware that cost as much as a house. And most importantly, Nobody knew they wanted it. Keyboards worked. Mice worked. This was an answer to a question nobody was asking. In 1983, HP released the HP 150, one of the first commercial touchscreen computers. It sold, but the touchscreen remained a curiosity, not a revolution. In 1992, IBM released the Simon, the first touchscreen smartphone. Stylus-driven, resistive display, 1-hour battery life, $900 price tag. It was 15 years ahead of its time. That's why it failed. The technology existed. Nobody knew what to do with it. 2002, Cupertino, California. Steve Jobs is looking at an internal Apple project, a tablet called the Safari Pad. Large screen, touch interface. He sees the potential immediately. He also sees the problem. A tablet stays on a desk. A phone goes in your pocket. Jobs makes the pivot. The touch interface moves from tablet to phone. The project gets a new name, iPhone. Apple's engineers spend the next 4 years solving the specific problems that had kept touchscreens off the consumer market for 40 years. Corning develops Gorilla Glass at Apple's direct request. Scratch-resistant, optically clear, thin enough for a pocket. Engineers build multi-touch signal processing from the ground up, allowing the screen to register multiple simultaneous contact points, something no consumer device had done before. Designers run thousands of iterations on gesture interaction, making the interface feel natural enough that someone could understand it in seconds with no instruction manual. Real work, real innovation, but not the invention of the touchscreen. When Jobs stood on that stage and said, "We invented a revolutionary user interface," he was describing a layer built on top of a foundation others had laid. Eric Arthur Johnson, 1965. Samuel Hurst, 1971. Frank Beck and Bent Stumpe, 1972. Apple paid none of them, credited none of them, named none of them on any stage. The first iPhone sold for $499. In its first year, Apple sold 6 million. In 3 years, 50 million. Apple has now sold more than 2.5 billion iPhones total. Eric Arthur Johnson died in relative obscurity. In most published histories of the touchscreen, his name sits in a single line before a paragraph about Apple, if it appears at all. Apple didn't invent the touchscreen. Apple solved the problem that made it unusable. That is a massive contribution. That is real engineering. But when Jobs said, "We invented," he was claiming credit for someone else's work. And the world believed him. Because in technology, the winner is not the person who thought of it first. The winner is the person who sold it first. Today, the touchscreen market is worth more than $70 billion. More than 7.2 billion devices. Every pocket, every hospital, every aircraft. Every time you touch a screen, you are touching Eric Arthur Johnson's idea. He received nothing from that market. He stood on no stage. His name is not on a plaque in Malvern. There is a pattern that repeats throughout the history of technology. Inventors come first. They see the possibility before anyone is ready, before the market exists, before anyone is asking the question they're already answering. They publish papers nobody reads, receive patents nobody uses, build prototypes that sit in laboratories for decades. Then someone else arrives with money, a team, and market timing, takes the existing idea, solves the remaining engineering problems, packages it in something beautiful, and sells it to billions of people. That second person is the one the world calls the inventor. The first person is a footnote, if they appear at all. It happened with the touchscreen. It happened with the graphical user interface. Xerox PARC before Apple. With the light bulb, dozens of inventors before Edison. Again and again. Apple deserves its place in history. Jobs and his team turned an abstract technology into the defining object of the 21st century. But Eric Arthur Johnson deserves to have you know his name. In October 1965, he wrote 2 pages describing a world that wouldn't arrive for 40 years, a world where people control machines with the touch of a finger. He saw it. He described it precisely, in writing, 42 years before it went mainstream. He built it first. He just never got paid for it. This is the full story.